So in number 17, we are informed that there are 9 red counters and 11 blue counters. So Emeka takes at random a counter from the bag, writes down the color, and then replaces it. And Natasha does the same. So, and then we have a tree diagram here to complete. Um, so basically, you add branches to the tree diagram. Um, so this represents the second event, and here we can have either a red counter or a blue counter, and red or blue. Now the probabilities basically stay the same. So the number of red counters is 9. So probability of picking red count in the first event will be 9 out of 20. And we have 11 blue, so that will be 11 out of 20. And this probability stay the same because the counters are being replaced. Yeah, so they stay the same because the counters are being replaced. And then the first question is work out the probability that Emeka takes a red counter from the bag and Natasha takes a blue. So a red counter, Emeka takes a red will be that, and Natasha takes a blue will be represented by that branch. So here, probability red uh, and blue will be equal to 9 out of 20 multiplied by 11 out of 20, which will be equal to 99 over 400. Okay, and then the second part of this question, work out the probability that, the third part of the question, work out the probability that both counters taken from the bag are the same color. So same color, that means the counters could either be red and red or blue and blue. So basically, again, same way, this represents probability same color. Could be either probability red followed by red or blue followed by blue. Now red followed by red, that will be 9 out of 20 multiplied by 9 out of 20. Or wherever you see the word or in probability, it means you add. That will be 11 out of 20 multiplied by 11 out of 20. And this will be equal to that will be 81 out of 400. So that will be 81 out of 400 plus 121 over 400, which will be equal to 202 over 400. Okay. Number 18. There are 52 cards in a pack, 12 cards are picture cards, 40 are number cards. Melina takes at random a card from the pack. She keeps the card and then takes at random a second card from the remainder of the pack. So she keeps a card, that means here is without replacement. So so basically here, because we have there are 52 cards and the number of picture cards are 12, so that will be 12 out of 52. And here we'll have 40 out of 52 because there are 40 number cards. Now, when one card is suppose the first card was a picture card, the number of picture card, and this is without replacement. So after the first picture card is picked and not replaced, the number of picture cards is reduced by 1. So here we'll have 11 out of 51. But because the first card was a picture card, the number of number cards are just the same, 40. So that will be 40 out of 51. And the same thing happens here. So the number of number cards, if the first one is a number card and it has not been replaced, then the number here reduces by 1. We'll have 39 over 51. But because the first card was a number card, the number of picture cards will be the same, so that will be 12 over 51. Okay, so then from there we can use the tree diagram to answer the remaining questions. So work out the probability that the two cards Melina takes are both picture cards, yeah, uh, or both number cards. So here we have picture followed by picture, or number followed by number. So probability number followed by number. And that will be equal to, so picture followed by picture, that will be 12 out of 52 uh, multiplied by 11 out of 51. And number followed by number, that will be 40 out of 52 multiplied by 39 over 51. And then you just work this out, so that will be 132 over 2652 plus 1560 over 2652. And this will be equal to 1692 over 2652. You can simplify that. To 141 over 221. All right, number 19. Felix has 10 cards. There are 5 red cards, 4 blue cards, and 1 green card. Felix takes at random one of the cards. He does not replace the card. So this is without replacement. Felix then takes a random second card, complete the tree diagram. All right. So we have some probabilities to start with here. So let's start from here, the red. So if the first card is red and this is without replacement, the second, so the second card, probability of picking a second card will be 4, because the number of red reduces by 1 if the first one was red. So 4 out of 9, but the number of blue are still the same, so 4 out of 9 here. The number of green are still the same because the first one was red again, 1 out of 9. All right, so if the first one was blue, the number of blue reduces by 1, so 3 out of 9. The number of red will still be the same, 5 out of 9 here, and the number of green will still be the same. If the first one was green, there will be no green anymore because it's only one green. Okay, so that will be 0. The number of blue remains the same, which will be 4 out of 9. And number of red will be the same, which is 5 out of 9. Okay, so work out the probability that Felix takes at least one blue card and no green card. So at least one blue means one blue or more. So that will be either that branch there, because that's one blue, or that. Yeah. So here it means that, so from the tree diagram, we have that will be equal to 4 out of 10 multiplied by 5. Okay, here we can start with the one at the top, 5 over 10 multiplied by 4 out of 9, or this one here, 4 over 10 multiplied by 9, or this one here, 4 over 10 multiplied by 3 over 9. So this will be equal to 20 over 90 plus 20 over 90 plus 12 over 90. And this will be equal to 52 over 90.